Hey, welcome everybody. This is part 2 of the 9.3 videos. The other video got cut off, so we'll just pick up right where we left off. So we're beginning to talk about outliers. And when we're talking about normal curves, an outlier is defined as any score that is more than 2 standard deviations away from the mean. So the key is more than. So we're going to end up calculating fences in this situation. And the fences are going to be found by taking the mean and then adding and subtracting 2 standard deviations. The nice thing is when we label a normal curve, those values are going to be defined already for us. The other piece here is talking about percentile ranking. So a score has a certain percentile based on the percentage of scores below that score. Meaning if somebody were to have a score that was in the 75th percentile, that would mean that they scored higher than 75% of the people who took the test. So that's how the percentile comes into play. All right, so using that information, we're going to label the curve and answer some questions. So in 2011, SAT scores have a normal distribution with a mean score on the math portion of the SAT as 518 with a standard deviation of 115. So we're going to use that information to label the normal curve. So we've got our mean, which is 518. We have our standard deviation, which is 115. So the mean is going to go right there in the middle, 518. As we go to the right, we're going to add 1 standard deviation, so we'll get 633. Add a second standard deviation is 748, and then a third would be 863. If we go to the left, we're going to subtract a standard deviation to get 403, then 288, and then 173. So again, just to kind of reinforce the idea, the middle value is the mean. This is plus 1 standard deviation, plus 2, and plus 3. Minus 1 standard deviation, minus 2, and minus 3. All right, so the next thing we're going to do is go ahead and separate our normal curve into our sections, and we'll identify the percentages. So we've got 34%, 13.5%, 2.35%, and then 0.15%. And again, we're mirrored on the other side. So 34%, 13.5, 2.35, and 0.15. All right, so now our questions are going to be worded slightly different. But in reality, we're not really going to be doing anything different. So for part B, what is the probability that a student scored less than 403 on the math portion of the SAT? So 403 is going to fall right here, 1 standard deviation below. We want to know what percent is less than. So the quickest way, in my opinion, is to take 50% and subtract 34%, so 16%. Now, probability can be written as a percentage, but it can also be written as a decimal. So 16% is the same thing as 0.16 if we're writing that number as a decimal. So should be familiar with those 2 terms. All right, part C. What is the probability that a student scored between 288 and 518? So 288 is going to be 2 standard deviations below. 518 is the mean. So in this situation, we're just going to go ahead and add the 34 and the 13.5, which is going to give us 47.5%, or as a decimal, 0.475. Now, when you're answering these questions, you don't need to write your answer both ways, but you should be aware that they are equivalent. All right, part D. What is the probability that a student scored between 288 and 633 or more than 748? So this time we have a couple different things we have to understand. So if we're between 288 and 633. And then more than 748. Basically we have everything in this range. So we're going to add the 34 plus 13.5. So there's 81.5% here. And then more than 748, that's going to be 2.5% here. Well, we need to add those two together, which is going to give us 84%, which is 0.84. All right. So hopefully that makes sense with those numbers. All right. For E, it says Terrence scored 750 on the math portion of the ACT. Is his score an outlier? Justify. So, again, there's that word outlier. And as we described earlier, an outlier is any score that is more than 2 standard deviations away from the mean. So, if we're looking at 750, here's 748, 750 is going to fall, on this side. Well, 748 is exactly 2 standard deviations below the mean. So we're going to go ahead and answer this as yes. All right, and the reason is 750 is more than 2 standard deviations above the mean. Let's go ahead and use the symbol. Okay. The key phrase being more than. If it's exactly 2 standard deviations, it is not an outlier. It has to be more than. All right. And then if we go ahead and we take a look at the last question here, we have Sarah scored 633 on the math portion of the SAT. The college that she wants to attend requires that students score in the 85th percentile or higher on the math portion of the SAT. Is Sarah's score high enough for her to be considered by this college? So, again, there's that word percentile. So 85th percentile or higher. So let's go ahead and see where 633 falls above. So if we take a look here, 633, that's right here, right at 1 standard deviation above. So the percentile is going to be everything below, essentially. Well, left of the mean is 50, and then we're going to add 34. So in this case, Sarah would score in the 84th percentile. So no, she did not score high enough because her score is in the 84th percentile. So she was very close, but not quite at that 85th or higher. So that's how that works. All right, go ahead and flip the page. And the last example we're going to look at is going to deal with a histogram. And a histogram is a type of bar graph. But one thing that makes histograms maybe different than some other bar graphs is that the bars are usually separated into groups or categories. So like the first bar represents 1 to 5, which in the context of this question are how many hours a student watched television in the previous week. So the first bar represents anybody who answered 1 through 5, and then 6 through 10, and so forth. So the bottom is number of hours of TV. The left-hand side is the number of students. So the height of the bar is going to represent the number of students. What I always like to do first is identify how many students fall in each category because we're going to need that information. So in the 1 through 5, the height of the bar is about 13. So we're going to say there's 13 students here. 6 through 10, right up at 35. So there's 35 students here. 11 through 15, there's going to be 17 students. 16 to 20 is a little above 5, so we got 6 students. 21 to 25 is right at 5 students. 26 to 30, that's going to be right at 3 students. And then 31 to 35, that's going to be 7 students. So you get an idea of what the heights are just to make it easier to answer the questions. For part A, approximately how many students participated in the survey? So the way we're going to answer that is simply add up the height of each bar. And when we do that, we should end up getting 86. So we've got 86 students represented in this survey. The next question, this goes back to 9.1. It says, describe the shape of the distribution. Well, if we look at the distribution, we've got most of the data over here on the left, and then you've got this tail towards the right. So this data would be what we call skewed right. Okay. Again, when we're talking about skew, we're looking for the tail. Which side of the graph has the tail? All right, for part C, it says approximately how many students watched 10 hours or less of TV last week? So 10 or less means we're going to add basically the first 2 bars together. So we've got 35 plus 13. So that's going to be 48. So we got 48 students. For part D, approximately how many students watched between 16 and 30 hours? So for 16 to 30, we're going to add this bar, and this bar. So 6 plus 5 plus 3 is going to give us 14. All right. Now, the next question's going to be a little trickier to answer. And again, this goes back to an idea we talked about in 6.1 with medians. So in which category is the median of the data? Well, to answer this, we need to make sure that we understand that when we're talking about median, we're looking for the middle number, okay, or the middle piece of data when the data is ordered from smallest to largest. So we know that there's a total of 86 students from question A. That means that the middle of 86 is going to be between the 43rd and 44th piece of data. And that's going to be key in our explanation. But so if these numbers were written out, if all of our data was written out, we want to figure out where the 43rd and 44th number are. And basically we would average them together to come up with the median. But all we have to do is find the category. So if you were to list the data, the first 13 are going to come from 1 through 5. The next 35 are going to come through 6 through 10. So once we list all of those out, we will be at 48 pieces of data. 43rd and 44th are both going to come from the category of 6 through 10. So that is our answer. Okay. And then to just kind of put that in words, the median is the average of the 43rd and 44th piece of data, which both are in the 6 to 10 category. So again, it's just important to remember when we're talking about medians, if there's an even number of data, it's between 2 numbers. If there's an odd amount of data, there will be a single term in the middle. All right, the next question. Is it possible to calculate the mean? So what you got to remember is mean is the average, which is where we're going to add up all the numbers and then divide by how many numbers there are. Well, in this case, we do know how many numbers there are, but the problem we run into is we don't know what the actual pieces of data are. So in this case, we are not going to be able to calculate the mean. So we're going to go ahead and say, no, we don't know the exact data. So we don't know the exact data. We know which category they fall in, but we don't know exactly what they are. So we don't know the exact values of the data. Okay. All right, and then the last question here says, which has a higher value, the median of the data or the mean? Explain. Now, even though we're not able to figure out exactly what value the median is or what value the mean is, we will know that the mean is going to have the higher value. And the reason is because the data is skewed right. And what happens is whichever direction the data is skewed, the mean is going to be pulled in that direction. So as a number gets pulled to the right, that means it's getting larger. So if data was perfectly normal without any type of skew, the mean and the median would be the same number. But in this case, we are skewed right, so that mean is going to be pulled to the right, making it larger. Or sorry, hopefully I said it correctly, but the mean is going to be pulled to the right, which is going to make that a larger value than the median. So hopefully this helped. Again, if you guys have questions, see your teacher and ask for help. Otherwise, I'll see you next time.